Oh, by the way, I should take this loading spinner off. I'm done thinking real hard. For now. She'll be back. She'll always be back. So we're going through the basic array problems on LeetCode, teaching some of my viewers about arrays and also yapping a lot about my math days as well. But the example problem here is it's the input is an array with some numbers between 0 and 9, so no double digits or anything like that. And we want to go through the array, and every time there's a 0, we just want to insert a second 0 after it. The naive approach that we started with is we loop over the array that's given. The array is no bigger than 10 to the 4th, which I think is 10,000? 10 to the 4th is 10,000, yeah. So we're not going to have any arrays bigger than 10,000, so we're not dealing with big data or anything like that. So we loop over the array for every element. If we find that that current element is 0, then we start shifting everything over to the right to make room for the new element, for the new 0, to make room for the baby. We're building the nursery for the new 0. So we shift everything over and then we insert it if there's space at the end of the array, because the problem statement said that if there's no more space at the end of the array, then we just yeet those off into space. So we check if we have space in the array for one more 0. If we do, then we insert the 0 and we are incrementing the counter just to make sure that we skip over that extra 0. Otherwise, we would just get infinite zeros as soon as we hit the first 0. So yeah, that was our naive approach, and that is O of n squared, which is pretty slow. So we're trying to see how we can make it a little bit faster. I think this was from Insertia. Insertia? I hope I'm pronouncing your name right. Yeah, this was from Insertia-sama, and I have become convinced that I can't improve on this. Yeah, because whatever I was thinking that, like, I could make this, like, just one tiny step simpler by not having to do, like, a check. But the path that I'm going down, I'm gonna have to do a check anyways. I'm gonna have to do all the same things that you did, so. Insertia, you have bested me. Let me look at, I want to see what the solutions have been, though. Looking for the big picture idea. I'm probably not going to reply. Well, yeah, let's see what the replies are, but I think the big picture idea is that first, we basically split up our concerns, where first, well, three big ideas, right? The first big idea is we're going from back to front, and the reason for that is because we don't want to overwrite data as we're going. We want to make sure that we still have access to the data that we're still working on. If we went from front to back, then we would be overwriting the data that we need to read. So that's why we go back to front. And then the second, like, big picture is that within that for loop, within those steps, once we're going back to front, then we have two main questions that we're, like, operating under. The first one is whether there's space for this particular value. There's, like, we're wondering, like, do we put the value in? Yes or no? And then the other question is, like, is it a 0? Do we have to add another 0? Yes or no? I think that's how I would explain the big picture. I hope that helps, Inquisitive Girl from May 2nd, 2020. Let's see what others have said. Oh, this is from the OP himself. Here are some more verbose thoughts since you are so inquisitive. This algorithm goes backwards and applies correct shift distance to every element. Why backwards? If we would start, oh, he even has 3. He's got 3. I think we're onto something here, Andre. If we would start shifting from left to right, then we would be overwriting elements before we had the chance to shift them. That is why we go backwards instead. We make sure we shifted out an element before we shift another one into its original position. Yeah, I agree wholeheartedly. What is the correct shift distance? The duplication of a 0 pushes all elements to the right of it by 1. This means also that every element is shifted to the right as many times as there are zeros to the left of it. For example, in the array 1, oh my god, we were using the same example too! Andre, my man! My boy Andre! Look at that! Look at that, same brain. Same exact brain. Wait, that wasn't in, like, the statement. No, that wasn't even in the problem statement. Look at us, we're just like, me and Andre are on the same wavelength. Why does that bring me so much joy? Okay, for example, in the array 1, 0, 2, 0, 3, 1 will not move, 2 will shift 1 position, and 3 will shift 2 positions. As we go backwards, every time we bypass a 0 and duplicate it, the shift distance decreases for the elements we haven't shifted yet, because there is 1 less 0 in front of them. Wow, that's a better explanation than I just had. My Python programming twin! Exactly. Oh. Andre is just me, but better. I respect it. Okay, and then why the less than n checks? Shifts push some of the elements out of the array. We do the less than n checks to make sure that we write down only elements that are shifted to a valid position inside the array, and we ignore the ones falling off the end. That's such a great explanation! Oh my god! Andre over here. 2-step verification is required. Alright, I'm not doxing my phone number on stream, so Andre's just going to have to appreciate my appreciation without having any idea that I appreciate him, but the goat. The actual goat. Amazing.